Hey guys, welcome to another episode, and today we have this big boy over here, which is Lenovo Legion 5. That's a 17-inch version. I'll show you the model in a second. Yeah, and what's wrong with the laptop? Well, it was supposed to have some liquid damage, and it came without a power supply, an SSD, or a Wi-Fi card or RAM sticks, so quite bare laptop. And I mean, the top cover, there's one scratch here, but otherwise it looks okay. I think this is just dirt, so probably it needs a good clean, maybe peeling off those stickers. I don't like it, so if we are able to fix it, I will probably remove it. Here's some, like, I think factory foil from the hinge. We'll remove that as well if we can fix the laptop. And as I said, it's quite a big one because it's 17 inch, and the exact model is Legion 5 17ACH6H. So that's it, and it has okay, let me show you the screen and palm rest. So screen is looking good, it's just a little bit dirty, but I don't see any scratches, anything, or signs of the keyboard on the screen, so that's fine. And the keyboard looks okay. Again, a lot of stickers which weren't originally here, so I will remove them if we can fix the laptop. Some cleaning, and of course it's the German keyboard, which I'm not very happy about. I haven't even noticed when ordering the laptop. But yeah, I had one already, just 15-inch model. So because of that, I have a power supply for the other one, so at least that. The other one, unfortunately, is probably dead forever, because I made it even worse. Yeah, that's a different story. Let's leave it for now. But the good thing is that I have RAM sticks, I have probably I can get the Wi-Fi card if needed, and the power supply, so that's good. Let's flip it over, and I have already removed the back cover. Actually, it came without any screws, so I just had to pry it, and right now it's loose because I already opened it, as I said. And I just had a quick look. By the way, the battery was connected, which is not a good thing, and of course it was completely drained, so I don't know if it wasn't charged for that long, or maybe because of some short on the motherboard. There is some sign of, I don't know, something like a liquid or maybe grease or something, I don't know. And also the CMOS battery was connected, and it's 2.7 volts. I already checked. We'll have a look again, but you can trust me on that. And I see some liquid damage here, like something sticky here, and I don't think it's any kind of glue to glue some elements to the board. I think it's liquid damage. I see some rust actually here already, or some, you know, liquid damage gunk. And of course we don't have RAM probably here. I mean, I would be surprised if we had. Let me lift it somehow. It's not that easy, but yeah, we managed. Okay, so as I said, it's empty. There's no RAM here, which again is expected. So let me remove the heatsink first, because without it we cannot measure the most important phases, so we'll have to do it anyway, unless we find a short somewhere here, which is the area where the liquid damage was. Yeah, but let's remove the heatsink and we'll continue. And we are back with the multimeter. Let's power it on. But I have some good news, I mean, possibly good news. So it was advertised as having Ryzen 7 5800H, I suppose, because it's 5000 series Ryzen, but it also said RTX 3060, which is 6 gigabytes, I believe. And as you can see here, we have 8 memory sticks, so that's most likely RTX 3070, which is very nice because it's a really nice GPU, or maybe even higher. I don't know if 3080 has more, but I'm not even sure if this series has higher GPUs, higher end GPUs. But if it's 3070, that's already great, assuming it's working. Okay, so let's start our measurements. Let's grab some ground, let's put it here in the screw hole. Let's just check on the USB if we have a good ground. Looks like it, 0.35. So that's good. Let's start with this area because here we have some liquid damage, signs of liquid damage. Let me check it. So let's look for a short. But okay, maybe first we don't have because I believe the MOSFETs, the input MOSFETs are on both sides of this, and there's no current sensing resistor here on this side for the main power rail. But let's check if we have a short here on the fuse. After the fuse, we don't have a short. And is the fuse good? Yes, it is. Okay. Checking ground again. It's fine. Okay, so let's check now. Let's check those coils here, the big one here, and we have hundreds of kilo ohms, so that's nice. Here we have 2.6, 2.7K, that's okay. Here we have hundreds of kilo ohms. Here we have 490 ohms. I guess that's fine. It's not shorted at least. Here we have what? 1.8 mega ohm. Not sure what that is. Here, that may be for the charging because the battery connector is here. Here we have 9.5K, that's good. Then we have this one here, that may be for RAM maybe or something. 52 ohms, no, probably it's not for RAM, but it looks okay, whatever that is. Here, okay, and now we have something here, that's probably CPU related as well. Let's check, 11 ohms, that's looking good, to be honest. Let's check other CPU coils then. That might be integrated GPU, that was most likely integrated GPU, and those are, integrated GPU, and those are CPU phases. Oh, it's not shorted, 4.9, that looks healthy and gives some hope, at least for the CPU, so all of them should be like this, and that's correct. Okay, and also let's check the main power rail, since we have those big caps here, and I said we don't have the current sensing resistor after the input MOSFETs. It's probably on the other side, but we can measure those caps here. So one side should be ground, 0.63, so it's probably not ground, so it looks like it's shorted, and the other side is 0.33, so that's ground most likely. And here is also very, very low, and it shouldn't be like this. So looks like we have a short on the main power rail, and well, I hope it's not GPU, it's not the GPU, because that might be GPU or a capacitor if it's that low. So for sure it's not CPU because it was 4.9, but so it's either a capacitor somewhere or we have a short to the GPU. So let's check the GPU now. Moment of truth. Oh, 0.37. I mean, it's super low, but it can be like this. It's actually almost like that short. That's too low, I would say, but I mean this multimeter is not that good, so and to ground we have, okay, slightly lower if I press it really hard, 0.27, 26, and here we have 0.36. It's going down, but does it go below 0.3? No. So maybe actually, I mean, I would say it's possible, it's okay, but still this resistance on the GPU is not the same resistance as the one on the main power rail, which is like 0.2 of an ohm higher, and that's actually, I would say it's good, because most likely it's not short to the GPU, and for sure it's not short to the CPU, so possibly both are good, and that would be amazing, to be honest. But let's check the memory VRAM for the GPU, and we have 32 ohms, and that's again perfectly fine. It's Samsung, so it's like perfect resistance. So as it is, we don't have any short, I mean apart from the main power rail, which is great, because that may be something, well, less serious, I would say. Let's check we have some BIOS chips, so I think this is the main one. Let's check it. Pin number 8, we have 9K, that's perfectly fine, and there's another BIOS chip here, and I believe this is for the GPU. Also, let's check it, and also no short over 1K. And we have a tiny coil here, I believe that might be something for the GPU, like PEX or something. Yeah, and it's 9.6 ohms, so that may be PEX actually. Yeah, so I mean it's looking great. That might be, you know, a really quick repair if it's something unimportant. We'll do visual inspection first under the microscope of this area. Like looking at this, I'm not sure what that is, but looks like a capacitor, to be honest, although I don't see any marking around it. Let's see under the microscope, maybe we'll see it better. So, you know, maybe it's as simple as a shorted capacitor here. And if we don't find it by visual inspection, we'll do a voltage injection and see what's getting hot, or even if we do, we'll confirm whether it's this or other element getting hot, and after also we will check if everything is fine. Okay, so looks promising, to be honest. I'm really surprised to get a laptop like this. Let's see what's going on. Alright, and we are under the microscope right now, in this corner, in this area where we had the liquid damage. And well, I cleaned the board pretty well. I cleaned pretty much everything. By the way, is it still dirty? No, I think it's just flux. Anyway, so I cleaned everything apart from this corroded element, which happens to be a capacitor. It's not this one. It was the one close to our huge coil, which was here, and the corroded capacitor is here. You can see it's looking, well, it's not looking good at all, and I haven't cleaned this on purpose. I'll do it in a second if we remove it. And we will remove it because, I mean, even if it's not shorted by accident, it's still corroded, so it needs to be replaced anyway. And then we'll search for another fault. But there's another coil here, which is probably 3.3 volts or 5 volts, I don't know, but the point is it has a capacitor here. I will use my multimeter now, but just go into the beep mode, so I'm touching the probes together, and it's beeping, as you can hear. And also, if we measure this capacitor, it beeps because, as I said, it has a short. So it's a capacitor from the main power rail. So now let's switch off the multimeter, and actually let's remove this capacitor right here. Where was it? Here. And even without the voltage in the injection, just to prove the point that sometimes you can fix things without having a thermal camera and even a bench power supply, let's remove that capacitor anyway and see and measure after if we get rid of the short. By the way, excuse me my voice, but I'm a little bit unwell recently, the last few days. Okay, where's my tweezers? And let's remove this guy here. Let's give it some heat. Okay, we probably need more solder. The more the better. Probably bigger tip would also be better, but I won't even bother changing it. We should be able to do it like this. We just need to heat it up a bit and push a little bit, and we should get rid of it. Oh, there we go. Oh, we have a blob of solder now. Come on. Oh, jeez. Okay. Let's just clean the solder, the excess of it. Let's thin the pads around here and clean the area. I can use not IPA but this other liquid I have for cleaning, this other cleaner, because it will also remove the rust and maybe sugar liquid if there's any here. And now we take a clean cotton bud and use some IPA. Okay. Okay, I can clean it better later. Anyway, I need to clean the laptop if we fix it. There's a lot of dust and other gunk everywhere, but now let's go to the other coil again. Where is it? Here. And that was our capacitor that was shorted before. Again, I'm in the beep mode. One probe, the other probe, and we have a beep. And now let's check. And we still have a short. Okay, so that means we'll have to do a voltage injection to find the short. Okay, and you can see the motherboard, the CPU and the GPU here. That's the corner where we expect a short, I would say, but it's not necessarily here. Let's see, and I'm injecting voltage. We have 0.9 volt and we're drawing 1.1 of an amp, and nothing getting hot here, but I can see already something pulsing here. See? Again. Okay, let's get my finger here. Okay, and let me show you under the microscope what that is. Actually, let's go closer. Let's zoom in so that you can see better. Maybe some contrast. Okay, and let's inject the voltage again. See? Alright, so we have it. Let me show you under the microscope. And we are back under the microscope, and I'm really surprised how comes I haven't noticed that, because it's close to the GPU coils right here. So we have one of the MOSFETs, the RMOS probably, and we have this. So basically the capacitor here is completely like everything underneath is blown up, and there's a lot of like charred PCB underneath. So definitely we need to remove it. Probably I have to, I mean, I can remove the capacitor now and see if it's any better, but honestly I don't think so with this level of burn. I mean, we need to remove it for sure, but maybe even the capacitor is okay. Probably it's not the source of the of the short, I mean, or maybe not the only one. All this carbon here probably is shorting layers of the PCB. So most likely we need to remove the board and remove those components here. See if we get rid of the short, and most likely, I mean, for sure we need to also clean this burn here until we are sure we don't have a short, and then we'll see. Alright, so as you can see, I have cleaned this area here, and finally I got rid of the short. So let me put one probe on the ground. Let me turn on the multimeter. Okay, so let's put the ground here. Let's make sure we have good ground. We have. Okay, so here's ground as well, and this big path here is 12 volts from the main power rail, and as you can see we have 1.2 1.1 mega ohm, and that's something I would expect from the main power rail, to be honest. Around 1 mega ohm, that's I guess perfectly fine. Then one layer below we have ground again, most likely. Can I touch it? Yeah, it's ground. Here we have what? Ground again. This here is 12 volts again, I think, because it should have the continuity to this thing here. Yeah, it does. So let's back to ground, okay. And well, we also did some damage. Well, I did, to be precise. So not sure if you can see it, but there is a trace going here. It's actually covered with the original uh, solder mask in between the traces, and the second part of it is actually here. So if I touch here, do I get any reading? 55K. And if I go here, can I get any reading? Probably not. But I was trying to figure out where it leads to. So I think we need to connect this trace here, and once it's connected, it should actually go here. I think I don't have a good contact. Do I? Alright, this one. So those are connected, and if I back to ground and check this one, do I get 55K? Okay, that's what we said. And this one, I can check it here as well. It'd be easier. Open line, so it's not connecting to anything right now, which makes sense because we broke the circuit. Yeah, okay. So, I mean, I don't know what else I missed, but looks like this is just one trace here. Then I need to cover it, make sure the ground is also covered, not touching anything, especially those two cannot touch, so 12 volts and the ground. This one here and this one here. So that's the most important thing, and I need to figure out those paths, like those, what those connect to. Those are connected together. This one here is also missing, so that was another pad. And there was something here, so probably I need to restore a few traces, and yeah, it's gonna be difficult and probably time consuming, but maybe we can do it. I'm thinking, I mean, since there's no short, maybe I could power on the motherboard as it is. But for example, with this signal, with this trace broken, there some signal might be missing, so it may cause the board not to start or not to start fully. And also I don't want to risk any short or something like this, so I'll try to rebuild whatever I can, uh, cover it with solder mask where necessary, and yeah, and then maybe try to solder back the armos. Uh, well, I mean, we'll try at least. It may not be that difficult, but I need to restore all the pads and maybe just connect with the wires. Uh, those pins here on the MOSFET connected with the wires to the components here. So yeah, quite a lot of fun, but I think it's worth trying. Okay, so we are under the microscope, and as you could see, well, I did remove quite a lot of the PCB, of the burned PCB basically, and I have managed to remove the short circuit. So if we now grab some ground, maybe like here, okay, you can see that, oh, let me sharpen the image a little bit, and okay, so this is our 20 volts rail, and as you can see, we have hundreds of kilo ohms, so that's good. And also, if we now um, check with the coil, okay, it's not, I cannot show the entire thing, but actually still we have the high resistance. So I'm not touching the ground, I'm touching the coil here, versus 20 volts. So we have hundreds of kilo ohms, so we don't have a short. Now I have covered part of the hole with the solder mask, and here you can see a wire, and that's because I did, let me grab the ground again, I restored a trace inside the PCB, and this was actually going from somewhere, going through here and going to this pin over here. And as you can see, we have 55 kilo ohms, and this is correct because I checked on the other board I have, which doesn't have a hole here, and actually in this area it's actually okay. So I have something to compare with, and I also have a donor that I can use to transfer some of the components. So like this capacitor here, those two I have, and this one I have as well. So if there was something here, I don't remember. But anyway, I have the rest, but I need this capacitor and I need the RMOS, so I can take those from the other board. So with that said, I think it's safe to power on the board, and we can see if the laptop gives a picture, if it works, and by any chance if the RTX is fine. As you can see, the laptop is assembled now. I assembled almost everything, just the back cover is not screwed in, but I put it back in place at the bottom, and well, everything works. The battery is connected, it's charging, it's working just on the battery without power supply as well. Wi-Fi works, all the drivers installed automatically on my test Windows SSD, like almost everything, but most importantly the GPU was detected correctly without any issues, no exclamation mark. So we have working RTX 3070, and as you can see in GPU-Z, all the parameters are here. 8 gigs of GDDR6 from Samsung, frequency, everything, sensors, everything works, all the technologies, everything is correct, and even the temperature is okay. Yeah, I mean the thermal pads are old, and I haven't repasted it yet, so probably I need to do that, but this is just a test. And well, right now we are running on 4 phases for the RTX only. So one phase, as you could see, was removed. I have removed the DRMOS, and we have a hole in the PCB, but I covered it a little bit with the solder mask. But right now, since we confirmed it's working, I will restore the PCB, restore the pads under the DRMOS, and we'll try to get the DRMOS from a donor. I have identical board as I already mentioned, so I will try to fix the PCB and install the fifth DRMOS so that we have all 5 phases working. This is also why I haven't stress tested the laptop. haven't benchmarked for like a few seconds just to see if it works. I don't want to stress it too much or make it overheat. So yeah, this was just to confirm if the laptop is working and if the RTX is still alive, and it is, so that's great news. Hope I won't break anything while restoring the missing phase. As you could see on the video before, I did some soldering and restored a trace, and now it's covered with solder masks, but I will put some more, so I hope the fifth phase will work as well. And as you could see, the laptop works. We're back under the microscope, and well, we can proceed and basically rebuild the PCB here, restore the pads and everything. But what I noticed is that I have the ground. Let me turn on the multimeter just to show you. Okay, so we have a multimeter, and now, as we said, we don't have a short here, and that's great. And I also need to cover the ground plane here because it's exposed. So here we have ground actually. Okay, those vias here, those are actually 20 volts. So if we grab 20 volts here, and let me go into beep mode, it will be easier for you to hear as well. So we have 20 volts, we have 20 volts here, and we have 20 volts here on those points. All those vias here are 20 volts. I just need to touch it properly. 20 volts. So probably I need to, I don't think I'm gonna run wires. I'll just restore the whole trace here, the big trace, and cover it, except for this area here where we need another pad for 20 volts for the capacitor. And I'll also restore this pad over here, which will be exposed, so that we can solder the DRMOS, as well as those pads here I need to restore. And the traces, not sure how I will do it. Maybe I'll just run wires to the pads here, maybe rebuild this pad as well here, but nothing else. But what I noticed, if we go get the ground again, this pad over here, it's quite low. It's not like that short, but it's like 4 ohms, so it's the same as here. And I checked on the other board, it is not like this there. Maybe because we have the resistor, but I think since we have ground here, I think it's slightly touching, and that's why we have such a low resistance here. So I think we need to grind a little bit here and make sure the ground is not touching this trace here in this spot. And then, as I said, we will continue and rebuild the whole area so that we can have a working phase again. Okay, the moment of truth. So I have restored the phase number 5 and everything is assembled, as you can see, except for the battery and Wi-Fi. We don't need it for now. We just want to check if the laptop starts. And well, if it does, then great, but we still need to check if the phase we restored works correctly. So if we have a working laptop still, then I will switch it off, disassemble the cooling, maybe put some small heatsink on the GPU and quickly measure the phases, and especially the phase number 5 with oscilloscope, just to make sure the wave is actually the same as the other phases. So I mean, let's see, let's connect the power. Hopefully we don't short anything. Yeah, let's do it. We had a small fan spin. Okay, let me open the laptop. Maybe that's what we need. And the power button is blinking, is on. And I think we have a picture, because I see some polarization on the screen. And yes, we have a picture, as you can see. So that's great, and probably we'll have some no boot device or something. Yeah, okay, so the laptop works, I think, at least it starts. So yeah, now we can check the phases. Okay, and as I said, we'll measure the phase without the heatsink and use the oscilloscope. So let's power it on and check if we have a working phase. Auto. We have on this phase and this phase, and looks like we have. Does it look okay? I think it does. My oscilloscope sucks, but it looks promising, so yeah, it looks the same to me. And I have the laptop fully assembled with all the 5 phases working, as you could see, and I ran the tests just for you to see. So and diagnostic programs, so you can see, especially GPU-Z, everything is fine. The memory, 8 gigs of Samsung GDDR6 memory. The card is detected without any problems. We have sensors, we have temperatures, everything. So everything's looking good. The delta between the GPU and the hotspot is really nice. Of course, it gets bigger up to like 10 degrees under load, but still it's pretty healthy. So no issues here, and everything works as expected. You can see the score of the GPU and the CPU and the overall from TimeSpy. So I think it's good, and it's typical for this combination of a CPU and GPU. Also CPU, no issues here. I put a Gen 4 NVMe SSD, 1 terabyte. So here are the results of the SSD. And well, everything is fine with the laptop. The only small issues that I noticed is that, so the keyboard works perfectly fine, but with the space button I noticed that it works, as I said, but it doesn't have that nice click that other keys have. So maybe since the laptop was liquid damaged, maybe there is like a drop or something sweet and sticky that sometimes make the click is not so, you cannot feel that click very well. But again, I checked all the keys actually working. You can see the space
here as well is working without any issues. All the keys are working as expected. I tested all of them off camera. You have the evidence here even. So yeah, it's all good. And anyway, I mean, this is a big laptop, 17-inch, quite heavy. I would expect most people to just keep it on the desk, so most gamers will probably also use it with a dedicated keyboard, like a mechanical keyboard or something. So I don't think it's a big issue unless you want to type a lot of text with it, but I mean, it's probably not meant for it. You could have something else to do that, right? So yeah, otherwise it's perfectly fine. And well, the temperature on the CPU was quite high as well. So if you just fully put a full load on just the CPU, it's fine. It's around 85 degrees Celsius, which I guess is not perfect, but it's perfectly fine, especially for a laptop and especially for a 8 cores and 16 threads laptop. But I noticed that when both GPU and CPU are under load, so basically in like 3D Mark, Times Pi, or basically any gaming scenario, the CPU gets hotter. And at first I used some good quality thermal paste on both CPU and GPU from Gelid GC Extreme, and the temperatures on the CPU peaked at around 100 degrees. So I thought, okay, maybe there's no good contact, but I actually removed the heatsink completely, and the thermal paste was perfectly spread and you know, making contact on the entire CPU die. So I applied PTM instead on both GPU and CPU, and the results are pretty much the same, to be honest. I'll test it a bit more for like a week or something. Maybe PTM needs some time to actually adjust, and maybe the results will be slightly better, but I think in general it's just worth having some kind of stand under the laptop. Perfectly ideally if it would be ventilated with some fans as well. So I think that's the perfect scenario for this laptop. I don't know, maybe there's something I could do. I read some comments on the internet, on forums, that people had similar issues with this laptop, so I guess it's the design. Some people made some modifications to add like a fourth screw to it to hold the heatsink, the pressure on the CPU better and more equal, but yeah, I'm not sure if I'm going to do that. But anyway, this I think is just a gaming laptop, and that's how it is. Yeah, otherwise the laptop is perfectly fine and perfectly working. So thank you for watching and hope you enjoyed the video. Thank you for watching. Leave a like if you enjoyed the video. Let me know in the comments what you think about this repair. And since you made it till the end of the video, I'm pretty sure it's worth smashing that subscribe button.